Welcome to Learn Live. Explore Azure Storage Services and create an Azure Storage account. I'm Scott Hogue. I'm a product manager in Azure Storage, focusing on Object and Data Lake. And in today's session, I have Carl with me. Carl, why don't you go ahead and introduce yourself real quick?
Hey, Scott. Hi, everybody. Thanks for joining us today. I'm Carl Rautenstrauch, also a product manager within the Microsoft Azure Storage team and card-carrying member of Bill's Mafia.
Can't get any better than that. Thanks to everyone for joining us wherever you are in the world today. Hopefully you're having a good day, morning, evening, whatever it happens to be for you. Carl and I are going to be covering two different Learn modules today. So we've got quite a bit of content to cover, and we'll be going pretty quick, but it's all topical and all in the same area. We're going to start with exploring Azure Storage Services, which is a module that covers, I would say, storage all up from the lens of both object storage or blob storage, as well as things like files and disks. And then we'll get into creating a storage account. So how do you make decisions about where your storage account lives? What type of redundancy should it be? And what are some of the features that you might want to explore as a consumer of Azure Storage? You can go ahead and go to the aka.ms links that are in the slide here and follow along with us as we go through our session. This session is live. Carl and I are both sitting in Florida, and we're ready to go for this. We would love it if it could be interactive, so please come to us with questions in the chat. We're happy to answer those. We're also going to do things like run through knowledge checks for these various modules that we're going through. We'd love to have you participate in those and let us know your answers to those questions as we're getting through. So with that said, let's go ahead and get into our first module, which is Explore Azure Storage Services. The core learning objectives of this module focus on Azure Blob Storage and where blob storage can be used. How do you pick when to use blob versus things like disks and files? We'll go ahead and cover all that. And we'll talk a little bit about blob access tiers as well to close things out, which is a bit of a cost-saving mechanism and cost optimization mechanism that's available to you as a storage customer. So just to ground us before we kind of get into talking about what is blob storage and what is files and what is disks, let's talk a little bit about a customer scenario and where these various components are going to fit into that scenario. So we have our friends at Tailwind Traders, and they're like many companies. They're on a journey to migrate their applications to the cloud. And those applications come in many forms. They have web applications that rely on things like static hosting. Think they have images that they need to store. They might have artifacts like PDFs or other files that they need to make available to users outside their organization. They also have applications that rely on things like SMB file shares and having access to shared data from one or more servers. And they, of course, have servers hanging around as well, both virtual machines and bare metal that need to come up to Azure, and they need to figure out kind of how to get all this over the fence and really land it not just in Azure as a straight lift and shift, but also a transformational exercise. So let's pick the right tool for the right job, given the constraints and kind of the requirements that are available to us. And as we're going through and we're kind of thinking about services within storage and the entire landscape, let's also keep in mind that we're going to have a little bit of a bent or be leaning towards platform as a service or PaaS over infrastructure as a service or IaaS. So basically, when we can, we want to be doing things in a way where we can rely on Azure services versus having to potentially take on a bunch of responsibilities about managing infrastructure ourselves. So in reality, that means we're going to be thinking about things like just straight PaaS services over virtual machines along the way. And there's certain see certainly some niceties kind of in the storage landscape that can get us there. So with that spiel out of the way, I'm going to turn it over to Carl to introduce our Azure storage portfolio to you.
Yeah, great. Thanks, Scott. And I love what you said there at the end. Really, we're gonna focus on let's call it more cloud forward or cloud optimized storage platforms that can help to unload some of that burden that many of you are used to with the granular management that's required of storage resources. And what you'll find in the portfolio that we're going to talk about today, we're going to provide some guidance for you around, is that's exactly what our storage platforms provide. So whether your application needs block storage, you need to mount a drive and use it as a raw device, or mount a drive to a server instance and format that with a file system to support a database application, a homegrown application, whatever the case may be, we bring you a fantastic platform with our Azure Disk Storage, which has a couple of additional services that rely upon our disk storage service in the form of disk pools and Elastic SAN that we won't really cover in detail today, but we will talk about the base disk storage services and some of the price performance tiers and advanced and unique capabilities that are available with this service from Azure. We're going to spend a lot of time, as Scott highlighted, with object storage. And our Azure Blob Storage and Data Lake Storage portfolio really has some unique attributes in terms of the way you can access those massive storage repositories and how they align to modern cloud-native applications. And then finally, as Scott stated, there are a lot of applications out there that need to continue to rely on traditional file protocols like SMB, also known as CIFS at times, and NFS. So we'll talk about the services that we have and some of the great edge to cloud solutions that we have as well in the form of Azure File Sync. So we'll spend a lot of time on these three today, and I think this will be very informational.
Great. So before we get too deep into things and kind of talking about this specific customer scenario, I just want to take a minute and call out where storage can be used across a number of workloads that exist out there. Whether you're doing things like migrating a traditional server, be it bare metal or a virtual machine, to Azure, you can take advantage of things like block, file, and object storage. If you're an SAP customer, you're going to be using virtual machines and file storage and object storage as well. If you're targeting, say, virtual desktop infrastructure, maybe you're looking at AVS or other offerings like that, you can go ahead and leverage things like Azure Files or even Azure NetApp Files for, say, an FX Logic share and getting your user profiles out there. If you're doing app modernization, like this customer is that we're talking about today in Tailwind Traders, you can certainly find your way to rationalize into either block or file, depending on your need. Maybe you're somebody like Tailwind who has a web server who needs to do some static object hosting, and blob storage is really good for that. Or maybe you're a customer who's already using containers on premises and you're looking for a way to do shared persistent volumes between your containers, and something like Azure Files and an SMB share might be a little bit better for you. Really, this is all to say that the storage portfolio in Azure accommodates a number of workloads and areas, be they cloud native apps, analytics, migrations. You're looking to virtual machines, PaaS services. We really cover everything from that whole spectrum of IaaS to PaaS, and then offering you a path forward with a storage offering underneath that. So with that out of the way, let's go ahead and get into some of our storage account fundamentals. So when it comes to storage services, like I'm just going to come into Azure and I'm going to work with storage, I kind of need to know what kind of storage I'm going to be working with. Am I using blob or object storage? So maybe I have a bunch of unstructured data. Again, I'm a web hoster and I have maybe static images for my website. Maybe I'm a data provider and I share data sets with external organizations in the form of CSV or Parquet, or I've got my custom binary image format and I just need a place to store that and I'm working with massive files. Blob storage is a great option for you. So you can bring that data over. There's multiple ways that you can upload and interact with your data and make it available to your applications either within Azure or to clients outside of Azure, be it maybe a mobile app that you've developed or just being able to kind of give users a link to come in and get at the things they need to. If you're dealing with virtual machines, you're going to be solidly in a disk storage offering. Every virtual machine in Azure needs at least one disk behind it so that it can have its operating system and it can boot up. And then you can attach more disks to that. If you have needs around specific performance constraints, maybe you're trying to hit an IOPS target, availability, things like that, there's going to be multiple offerings in the disk portfolio that Carl and I will take you through just a little bit later. And then, of course, we have Azure Files, which is a PaaS service and offers common protocol access to files that you might want to store in Azure. So if you're doing things like SMB file shares or CIFs, as Carl called out, maybe you're even doing NFS 4.1 shares, you can stand up Azure Files inside a storage account, create a file share, and then make that data available to wherever it needs to be, whether that's virtual machines that are hosted in Azure in the same region, same subscription that you're in. You're exposing SMB shares, so you can do interesting things like bring those back to clients. There's broad support for hybrid there. You can even do things like leverage your identities in Azure Active Directory and secure your files in Azure Files. So we'll dive into that a little bit more when we get to the files section. Just to briefly touch on it, I also want to cover redundancy in storage accounts. We'll talk about this a little bit later when we get to our next module, and we're actually kind of going through provisioning an account. But there's multiple options when it comes to redundancy for your data when you're creating a storage account. So at its most basic level, we have LRS, or locally redundant storage. I'm within a single Azure region and within a single data center within that region. If you need a little bit more durability in your data, you're looking to increase resiliency, you can step up to zone redundant storage, or ZRS. ZRS is a replication model for storage where, rather than having only one region and one data center for hosting your storage account, the data in your storage account is hosted in one region, but across multiple availability zones within that region. So kind of in the example here, we have a region with 3 availability zones: zone 1, zone 2, zone 3. Your data, 3 copies of it, are stored in each zone and providing you resiliency to things like a zonal outage. We also have geo-redundant storage, or GRS, which is where you are going to have multiple replicas of your data that is distributed between 2 regions. So every Azure region has a sibling or a paired region. I'll call out East US is paired to West US. So if you provision a geo-redundant storage account where your primary is East US, we'll automatically replicate your data over to that secondary in West US. So if the primary ever goes down, you have an option, if Microsoft ever executes a failover, to make sure that your data is available. There's other models within GRS. There's both GZRS. So we have a model for geo-redundant and zone redundant kind of combined together. And then we have the last option, which is on the slide here, which is RAGRS, or read access geo-redundant storage. So if you have data that you want to have available in two geo-distributed regions, and you want the data in the secondary region to also be readable, maybe you're doing that like you have an East Coast and a West Coast presence for your business, and you want latency to be reduced for users on the West Coast when they're accessing that data, we'll automatically replicate it for you, and those clients can just come in and read out of that secondary endpoint. So with some of those basics out of the way, I'm going to go ahead and turn it back over to Carl, and he'll tell you how you can start moving your data to Azure.
Yeah, thanks, Scott. And the fact that we have all of those redundancy levels, and we have kind of automated the protection that many of you have to do today manually through a couple of different technologies, is one of several reasons why customers are moving data from their existing environments to Azure, and of course the applications along with that. And for many, many years now, we've offered a great service called Azure Migrate that allows you to move block-based storage, disk-based storage that happens to be attached to virtual machines and physical servers to Azure in a very, very automated means, which brings, of course, the application along with it and allows you to automate and test and have assurances that your application is going to move and operate in Azure properly. Now, there are cases where Azure Migrate does not yet support a scenario. One, we have our new Elastic SAN offering. So for customers who want to move a SAN-based application to Azure from their current on-premises SAN to Azure Elastic SAN, our great partner Cirrus Migrate can help with that. They've got a fantastic service for doing that. And then in the file and object storage realm, we have our AZ copy utility that we've had for years. And for those of you who aren't familiar with it, the best comparison I can give you is to tools like RoboCopy and rsync, where you're running a command line utility with several parameters and options, and you're able to migrate sets of files and directories at a time over the wire using that tool. We recently released into private preview a service called Azure Storage Mover that we intend to expand the scenarios that it supports. Today, you can use it to migrate from an NFS export to Azure Blob Storage. You'll see more scenarios added. And of course, for many, many years now, we've offered the Azure DataBox family, which is an offline, not over the wire means of migrating data to Azure. Bulk data on either disks that we provide, we ship, small appliances, and then really big appliances that are on wheels that you need to push into your data center. And about a year ago, we launched the Azure Storage Migration Program with two of our great partners, Comprise and Data Dynamics, where you can use their tools for free to fully automate object, S3 compliant object, and NAS or Windows file server, Linux file server based workloads, so SMB, NFS sources, to Blob Storage, Azure Files, and Azure NetApp Files. Great program. We've had many, many, many customers take advantage of it. And these two wonderful partners do a fantastic job of automating that process, educating you on how to use their tools, and helping you to accomplish those migrations quickly and with no risk based on just how easy to use and how fully functional their tools are. So great tools, techniques, and technologies that you can use to migrate your data sets to Azure to support all those applications you're bringing as well. Great. So let's see. We're going to spend a little time on disk storage now. And I'm going to go ahead and kick things off for us here and talk about some of the virtues of our disk storage platform. One of the things that we're really proud of, and I think we should be, is the fact that we are the only public cloud provider to have built-in replicas and built-in protection for our disk storage. So you don't have to worry about host level RAID or the type of elaborate, complicated techniques within a virtual machine to make sure that you're protected against a hardware fault. We do that for you. We create 3 replicas, and we can do that in the locally redundant storage model that Scott talked about earlier, or the zone redundant storage model. So some great technologies that we bring to bear that allows us to offer our single instance SLA for our disks that are deployed in this manner. And that is a 3 nines SLA, which again is the first in the industry by virtue of that protection scheme. We have worked with partners like Cirrus Data. They were a great example to help make migration easier. We have open APIs that they can use to efficiently and effectively migrate data to our disk storage devices. And we continue to grow that ecosystem and support our partners with every capability that we offer to first-party services like Azure Migrate. And then finally, I was really excited to see this when I was an IT sysadmin. I deployed a lot of Windows failover clusters. And in order to do that, you need a disk storage platform that supports reservations that allow for access and handoff of access on those disks. And that's a capability that we released years ago in our premium and ultra disk SKUs that allows you to run mission critical applications requiring failover cluster support or Oracle rack style deployments that mean you can bring your most business and mission critical applications, disk-based applications, to Azure. Scott, why don't you walk us through the performance tiers that Azure Disk Storage offers?
Sure. So there's multiple performance tiers, and really you can potentially mix and match these two if you want to. So as I talk through some of these things, don't think, oh, I can only use standard hard disks on one of my virtual machines. I can only use premium or ultra on another. To a certain degree, you can mix and match things here. But you have the ability to choose based on your application's requirements and your business needs, the performance that's associated with any given disk that's associated with your virtual machine. So that comes in a couple different flavors. You can choose things like, what's the size of my disk? Maybe I'm doing something like an operating system disk and I only need 512 gigabytes. Maybe I'm doing a larger disk that's hosting something like my SQL Server database and I need 32 terabytes for that. You can certainly work up to those levels. I think the most important thing when it comes to disks is recognizing what type of performance you need out of it, and are you going to be able to kind of grow within a given tier. So you kind of have to pay attention when you're creating a disk in Azure that you're getting the performance that you need out of it, be it things like bandwidth or IOPS, input output operations, or kind of the transactions per second that you can go ahead and run off that disk. Any disk that you create today in Azure on a virtual machine is going to be what we call a managed hard disk. So you don't have to worry about things like, what storage account do I put that disk in? Where does that disk live? We handle all that for you on the Microsoft side. You basically say, hey, I need a disk. I need it to be this big at this scale with this perf, and we'll do the rest for you. You're still in full control of your data. You control things like role-based access control, and not only what virtual machines, but who as a human has access to that VHD, and you're off to the races from there. Another really cool thing that I'll call out here is you can do things like stripe disks together as well. So if you're in a particular offering, like say I think standard disk is going to be enough for me, but I really need 10,000 IOPS and not 6,000, I can actually go into something like Windows and create a storage space and stripe those two disks together and effectively double my throughput across kind of the shared disk that I go ahead and present back to the VM. So lots of options available to you there. You can also do things like always upgrade a disk later. In some cases, you can go from things like standard to premium. Varies between VM series, but it's certainly something that you can explore if you want to go down that path. So Carl, go ahead and turn it back over to you. Talk a little bit about workload performance.
Yeah, absolutely. So I'm going to start with choosing the right VM. You saw some staggering performance numbers at the bottom of that last slide in terms of number of IOs per second for the different disk types and amount of throughput or megabytes per second for each one of those disk types. Well, just as we have different performance tiers within the disks, we have different price performance tiers within our VM platform as well. So if you need the highest throughput possible for your application, you want to make sure that you've chosen a VM SKU that can map to the underlying disk capabilities. So all of this information is public on our learn.microsoft.com documents for the virtual machines and the VM disks. So just make sure you have a good pairing there. Obviously, that applies to the disk as well. Still, those statistics are available. You saw some of them on the last slide. Scott had a great point there about being able to add host caching capabilities. The lowest cost IOP you can ever have is the one that doesn't have to leave the host, right? If you're able to service that read request, buffer those writes at the guest before you go over the network to hit those disks, that's always going to lead to a better performance experience. So host caching is a great way to enable that. And then for folks who have been working in the storage realm for years, or say you just really dive into application best practices, you're going to be familiar with that last point. Isolating IO and IO of different patterns across discrete disks is a great way to ensure best performance. Those of us who have been working with Windows and Linux for years know you want to put swap and page files in a different location than where your application files, your databases are going to reside. Within your databases, you want to separate logs and tables. These fundamentals don't change when it comes to the public cloud. These are just the realities of the operating systems, the IO queues. So bring those same best practices with you to Azure, and you'll be rewarded with great application performance. Now, we do want to show you a couple of quick demos today. So I'm going to switch over to my Azure portal, and I'm going to walk through really quickly selecting and adding disks for a VM. So first of all, let me refresh and log back in. And what I'll do is, rather than walk you through creating a new VM and selecting disks at creation time, which you can absolutely do, and the majority of you will do as you're building new VMs, it's good to know that you can also add disks after the fact to an existing VM. So whether it's to expand that application, install a new app, deploy a new workload on a VM that already exists, you can go ahead and do that. And it's as easy as hitting the create and attach a new disk, naming it, choosing the disk type, the performance standard that you want to use. Is this highly demanding, extremely high IOs? I'm going to go with ultra disks or premium, or is it less demanding and I can get away with a standard SSD or standard HDD? And then, of course, I need to choose the size for that. You can see that we provide right in the portal exactly what those performance statistics look like for what you've chosen. And I can use either platform managed encryption keys for encryption at rest, or use my own key I'm providing from a key vault, and then select my host caching policy at that time. And as soon as I choose those parameters, I go ahead and hit save. That new disk will be created. It will be attached to the VM. I can log in, I can format that with a file system, and I'm off to the races. So it really is that easy to add disks to an existing VM. Adding them to a VM at the time of creation is just as simple as add another disk, and just keep going through that same wizard, and you are up and running in no time. So we're going to switch gears now. It is easy. It's beautiful. It is beautiful. And now we're going to talk about something completely different. Was it Monty Python, right?
Perfect. Yeah.
Let's switch gears and talk about Blob.
Let's go ahead and get into blob fundamentals. Before we get too deep into this, I will say there's a lot more to explore on the disk side. You can certainly get into things like data recovery, snapshots, backup, all that good stuff, also offered on the Azure side. So don't let your journey stop here if you're just getting started with disks. There's a lot more to go out there and learn about. So on the blob side, before we get too deep into it, I'm going to let Carl take just a minute or two and kind of talk about multi-protocol access on our platform and how we view that and how that can help you as you're bringing your workloads to Azure.
Yeah, absolutely. So when I started with the storage team, oh boy, many years ago, over 5 years ago, we offered one way and one way only to access the Blob storage platform. And that was through our Blob REST-based APIs. So you had to be a developer or you had to use an out-of-the-box application that was using those APIs in order to read-write data from a Blob storage account. So over the course of the last several years, we found that our customers wanted to have a single store for their data and be able to access it with different types of applications that leveraged several different protocols. So we started with Data Lake. We had to add a hierarchical structure to object storage, which object storage by its nature is not hierarchical. It's a flat, big bucket that you put data in, you put files in. ADLS allowed for structured formatting, like files within folders and nested directories and things like that. We also added the capability to access that through an HDFS style protocol. So big data analytics applications were now able to use that blob storage natively, like they would a Hadoop file system. Then we added NFS3 protocol. There are many legacy applications, especially in the high performance compute space, that rely on NFS v3. So now that same storehouse that you may be using to feed a data lake and an analytics application, you can also run that HPC application using the native protocol without having to rebuild it from the ground up. And then a fantastic way to ingest data, make data accessible to multiple platforms is through SFTP. So we recently added SFTP to make it easier than ever to get data into blob storage and also pull data out in a controlled fashion with a protocol that many of us have used throughout our careers. So we are working to build a really intelligent platform with Blob that not only offers these protocol capabilities, but some advanced functionality that we're going to talk to more in depth for managing that data as well.
Yeah, it's definitely really a unique offering, and I'm constantly surprised about it. Like when I'm working with customers, I think another thing to call out here, very much like disks, where you can mix and match, you can mix and match protocols as well to a certain degree. So if you want to do things like ingest all your data over the Blob API with, say, a tool like AZ Copy, and do a big bulk upload, but then be able to read that data like a raw data set inside of an analytics framework like Databricks and be able to transform it into, say, like Parquet or Delta, something like that. You're working with the data in the same place. So you don't have to have two copies of the data. It's all one storage account with these multiple protocols on top of it, which is super powerful once you start getting into it. And I think, have the time to wrap your head around it and how all that comes together. But not to harp on that too much. We've still got a lot of content to cover, so let's keep going. Blob storage in general, it offers a couple of different types of blobs. Blobs are binary large objects. So anytime that you upload an object to your storage account over that Blob API and that REST endpoint, it can be a block blob. So think basically any kind of unstructured data that's comprised of one or more blocks of data. That could be something, like a simple PNG, and maybe it's a couple megs and it comes up as just a single block and it's a single object. It could be something large like a VHD that you uploaded from someplace else, and that could be 100 plus terabytes, and it's broken into a bunch of small pieces and then reconstituted within the Azure platform. Disks are also a type of blob. So when you're using those managed disks and creating them through either the portal or the CLI or PowerShell, whatever your tool of choice happens to be. Those all live as VHDs and page blobs within the storage platform. We also have this thing called append blobs, which are great for objects that are going to grow in size over time. I work with a bunch of ISVs who do things like write telemetry to the Azure storage platform. Like, it's great to have a single object that can start out as a base size, and then you can keep appending more data to it over time, up to the limits of what we allow in a single object within the storage platform. If you're dealing with blobs, like you're creating a storage account and you're working with that object storage piece, you're really going to be working with block blobs and append blobs. I think page blobs for this point kind of fall into that managed offering over on the disk side. Within blobs, once you have them there, you have these storage tiers that are available to you, which allow you to have things like cost controls around the data that you store. Not everything that we upload to storage needs to be immediately available 24/7. We might not be reading it every day, every second. We might read it once a month. And if we only read it once a month and it's not very hot data, maybe we want to store that in a storage tier like Cool Storage, where we have a lower cost and for the data stored, but a higher cost for the transactions against it. So you can always balance this within your storage account. And the cool thing is, you don't have to have a different storage account for your hot data and your cool data. It can all be in the same place. You can mix and match and move that data between tiers. If you have data that you need to store a long time and you're never really going to read it, but it just needs to be there, maybe you have a regulatory constraint or something that you're trying to meet from a compliance perspective, or you're just trying to achieve the lowest cost and you know that you don't need immediate access to your data, you can use things like the archive tier, which you'll send your data to the archive tier. And then once it's there, if you ever want to retrieve it and read it, you'll submit a request and we'll rehydrate that data for you and bring it back over to something like cool or hot. So then that object is readable again. Carl called out in the kind of previous little piece about how we have this hierarchical namespace within our multi-protocol strategy. Blob storage sits firmly in the flat namespace side of things. So when you upload an object, we let you do things like include a / in a part of that object path, effectively giving you virtual directories, but those aren't real directories. So if I ever wanted to say come through on the object side and enumerate a directory, I would really be doing that maybe based on an entire segment of a virtual directory path. It's not like having a real file and folder like you would get on the hierarchical namespace side of the house, like maybe where I want to move a folder, rename a file, things like that. In Blobland, if you want to rename a blob, that really means re-uploading it and giving it a new object name and landing it in the right path along the way. We also have Azure Data Lake Store Gen 2. I think it's important to call out that this is here. This is kind of one of those primary offerings that's built out on top of hierarchical namespace. When you are using Azure Data Lake Store Gen 2, you're still using a regular storage account. So just keep in mind in the back of your head, like I mentioned, you can have blobs and HNS data residing within the same account, and then you're kind of choosing the tooling and the protocol that you want to access things with. It's a HDFS compatible file system that's presented back. So if you're using standard analytics tooling, maybe you're just using HDFS. So for something like HD Insights, you could be a Databricks customer. You could be somebody who's using Synapse, Trin.io. Like there's lots of options out there for you. And you can access all that data on top of your hierarchical namespace. This is an option that typically most customers are going to set when they create their storage account. You can also come back later and say, maybe you thought you were going to be able to get by with a flat namespace, but it turns out that you really can leverage some of the features of hierarchical namespace or HNS. You can also go ahead and execute an upgrade on that data and be able to convert your account. All your data stays in place. It stays online the whole time. And it just kind of lights up with these new protocols and these new ways to access and interact with your data. When we're comparing HNS or hierarchical namespace to that flat namespace, these are true hierarchies. They are and file systems. It is not a flat namespace. So you're working with real files and real directories. So I can do things like rename a file in place. I can rename a directory. I can move a directory within the hierarchy, copy things around. It really is a great offering and just part of that overall storage ecosystem. So with that being said, let's keep moving and we'll get into files fundamentals at this point. Files is an offering within storage. So much like maybe Blob or HNS or SFTP, we also have this endpoint for files within a storage account that gives you access to common file sharing protocols. So specifically, that's things like SMB and also NFS. And you might be looking at that and saying, hold on, didn't we say that NFS was also available in Object? It is, but you just have to keep in mind there are different versions of NFS. So the NFS that's built on top of Blob is NFS 3.0, and NFS that's built on top of Azure Files and available to you is NFS 4.1. Files are just like anything else in the object storage platform. They, can use the same types of redundancy offerings. So we talked about like LRS and GRS and ZRS. They're encrypted at rest. You get 3 copies of your data stored. So really it's a nice kind of complementary offering to everything else that exists within the storage stack. When it comes to Azure Files and how you interact with it, all you need is a storage account. And within that storage account, you would provision an Azure file share. You can have one or more file shares in a single account. Depending on the needs of your application or your business, you might choose to maybe do 1 file share per storage account. You might have 10 file shares in this storage account, 1 in another. You can really do whatever you need to along the way with that. And then at that point, it's up to the types of clients that are going to be accessing your data. So maybe you're working with Linux clients and they require NFS. That's great. You can light up NFS 4.1 on your file share at the time you provision it. And you'll get access from those clients. Windows clients and Linux clients, Mac as well, all support SMB. So you have the option to go ahead and connect that way. You can also connect to these cloud-based file shares privately over private networking. Maybe you do like a site-to-site VPN or even potentially like a point-to-site VPN back to a limited number of clients that exist out there. Lots of options for you. Another thing that you can do is you can bring your data closer to your users. So I talked a little bit about GRS earlier and models like RAGRS, where you can have readable data that's in a secondary region. Azure Files also offers a capability called Azure File Sync. So you can bring a local server closer to your users and effectively have a hot cache for them that's available for those users to interact with And then the file sync server and service handles making sure that any data that's written to that local, say like regional or in my office based file sync server gets replicated up to my file share. And then any other clients that have access to that file share can go ahead and interact with it. Sky's the limit when it comes to access here. You can have on-premises clients like we've kind of called out here, or you can have clients within Azure as well. Those could be servers within Azure. They could be virtual desktops, again, within something like AVS, or just, hey, a persistent volume in a sidecar for your container. So a ton of flexibility there when it comes to provisioning and how you access your data within Azure Files. So Carl, why don't you take us through file sync real quick?
Yeah, fantastic. And before we get into file sync, I do want to respond to the question from Jens about migrating files from a Linux-based web service to Azure and preserving the dates, the creation dates. It's really going to depend on the target where you're migrating to. So whether that's Blob Storage or Azure Files, and the semantics that are supported by the copy tool. So I would encourage you. We've got a great article on migration. If you head to the tech community and the Azure Storage blog, you'll see my most recent post is on the Azure Storage Migration Program. I linked to some of our guidance there, comparisons of the tools, because there are ways to do that. Our partner Comprise, for example, who's part of the Azure Storage Migration Program, the free Azure Storage Migration Program, can copy those and preserve those creation dates if you're migrating to Azure Blob Storage or Azure Files from a Linux file server source. So there are ways to do that. It's most likely the tools target combination, and I'd encourage you to look through our documentation, and the blog post is a great way to get links to the relevant documentation. So fantastic question. Keep them coming, folks. So Azure File Sync is a tool that we built to make it easier for customers to leverage all of the great attributes that Azure Files bring to the table from a PaaS perspective, a data protection perspective, and offer a means to still have that local file share access experience at one or multiple sites that you may have spread across the world, really. So file sync service involves a Windows file server running the file sync service that sits in that local office. Yes, it can be virtualized. It does not have to be a physical server. And then your end users are going to be able to connect to that to get cached copies of files without having any cloud latency, depending on what your network and physical location realities may be. And it keeps that content synchronized with an Azure file share. So you have your data protected there. It gives you a means to tier data as well. So rather than maintaining a large local file server in your office, you're able to maintain a small instance, and the bulk of the content, that cool content that's not being accessed regularly, is going to live in the cloud in an Azure file share, and not cause you to build up a lot of unnecessary infrastructure. And it does that based on age. You can set policies and watermarks, and you have great controls over that. And by having that master golden copy in Azure Files, you're also able to move backup of that content to the cloud and use Azure Backup to protect all of those files from one or multiple offices without having to have backup in the form of a tape library or a data protection appliance in your office environment. And then from a disaster recovery perspective, this is what I love. And Scott and I, both being from Florida, we think about this a lot. What happens if that office, equipment in that office, is damaged due to flooding from a hurricane? Or pick your disaster, even ransomware. I mean, it doesn't have to be a natural disaster. It can be a ransomware infection. what Azure File Sync allows you to do is to quickly recover using the data that is in the cloud, that is protected by Azure Backup, and have those files accessible to your end users from a cloud-centric share or another Azure File Sync server that has been resynchronized when it's deployed. So great tool. We have folks who use this constantly. There's that DR scenario animation. That server can die. You can replace it and get your content back. Get that frequently accessed content back. So highly recommend exploring Azure File Sync if you have Windows file servers in your environment and you've been thinking about modernizing that experience. And we do want to spend some time on Azure NetApp Files as well. You saw early on that we have two different offerings, Azure Files and Azure NetApp Files. Azure NetApp Files is a modern, cloud-native instance of NetApp's industry-leading file sharing capabilities, file service, running in Azure. It is extremely high performance. It runs on bare metal NetApp hardware. It allows you to migrate those enterprise NAS workloads that require advanced snapshotting and selective replication and features and functions and performance that really push the boundaries of file workloads to Azure. And a great example of that is Azure VMware solution can use Azure NetApp Files as the data store to host your VMDKs that are attached to those virtual machines. That's something that customers have been doing for many, many years now. NetApp is an absolute leader in that space. And the Azure NetApp Files offering allows you to do that and other demanding workloads like Oracle databases, SAP, and many, many more. Extremely high performance offering. So oftentimes we find that customers will end up using both, some Azure Files, some Azure NetApp Files. And there are a few distinguishing characteristics between the two. One is when you compare side by side, the performance capabilities of ANF tend to exceed Azure Files on a fairly consistent basis. Multi-protocol is a big one. We highlighted that Azure Files offers SMB and NFS protocol support. It does not offer both from the same file share, from the same share within the account. So if you have that need, Azure NetApp Files is the way to go. Simultaneous NFS and SMB protocol support. More NFS options there, version 3 and version 4 in the same deployment. And of course, many generations of SMB. Really, between these two, there's more granular differences that are going to depend a lot on your application needs. And I would encourage that you view the comparison that's available on docs within our Microsoft Learn content. So well worth investigating if you're not quite sure, even after hearing those high-level differences between the two. Excellent. Okay, well, let's switch gears and head back to Blob. Scott, why don't you walk us through the tier options that we have?
Yeah, let's get into it. So I mentioned a little bit earlier that there's a couple different tiers of storage that are available to you, basically, rationalized based on how much you access your data. So is this something that I read every day? Is it something I write to every day? Is it something that maybe I access once every other week? I access it once a month. I access it once a year, or I really just rarely access that. So within a regular storage account, I'll call it a standard storage account. When you go ahead and create your storage account, you're going to choose whether it's standard or premium. We technically have 4 tiers. So premium is a standalone storage account offering today. That is going to be your highest cost for data stored, but lowest cost for transactions. And you're also going to have your best performance when it comes to time to first byte or latency for accessing your data. Latency and time to first byte in the premium tier is measured in milliseconds, whereas hot and cool can be measured in tens of milliseconds. But all to say, if you put your data in a storage account, you can manage the life cycle of that data and pick the tier that's right for you based on your application, based on how frequently or infrequently that data is accessed, and then any kind of regulatory compliance needs that you have around it. We also have a robust set of capabilities around automatically managing data lifecycle and being able to go ahead and tier automatically. So you can do things like start with your data in hot and then automatically have that data move to the cool tier so that you can save more on storage costs if it hasn't been accessed in a certain amount of time. Say, if this blob hasn't been accessed in 30 days, I want it automatically moved to cool so that my storage cost is lower at the expense of transaction cost. And you can do the same thing in reverse too. You can say, hey, I sent that object to cool automatically, but now that if I see that it's starting to get red again, let's go ahead and just move it back to hot and bring it up to a tier where I'm going to enjoy better cost around things like transaction. Premium, hot, and cool are all effectively online tiers of storage. You can think of archive as an offline tier of storage, or really a tier of storage that doesn't offer you immediate access to your data. You basically have to rehydrate everything from archive and move it back over to something like hot or cool to be able to read it. So where hot and cool, time to first byte is measured in tens of milliseconds. Time to first byte in archive can be minutes and sometimes measured in hours, depending on the type of rehydration requests that you submit. We have both priority rehydration and standard rehydration, and then how much data you're rehydrating. So if you do a high priority rehydration for an object up to 10 gigabytes in size, you can go ahead and typically rehydrate that within an hour. So let's go ahead and take a real quick look here at a demo for setting some access tiers on a blob. I'm going to hop over to a storage account that I already have created. Cool thing here, we can do all this within the portal. We don't need to use any SDKs. We don't need to go and use a REST API. I can do all this within from within storage browser. I could go and configure some of those lifecycle management rules that I talked about directly from in the portal as well. If you're happening to use client tooling, like maybe you use something like the Azure CLI or Azure PowerShell to interact with your data, you can absolutely do that tiering within those tools as well. All these things are doing is calling kind of the same REST API on the back end that's available within the storage service. So right here, I have 3 CSVs. They're already stored in my storage account. I can see when they were uploaded to the service. That's based on their last modified date. They're all block blobs. I'd be able to see if they're an append blob, page blob, things like that. And I can see the access tier that they're all in. So right now, my storage account is configured by default for everything I upload to land in the hot tier. I could have configured that so that everything landed in the cool tier. I just happened to choose hot for this one. So I took this first blob and I said, okay, it's hot. And I just cloned it, made a super quick copy of it and snapshotted it, like give me an exact copy. And now I have one that I want to move over to the cool tier. I'm just going to right click that object and say change tier. What access tier do I want to move it to? I want to move it to cool. And instantaneously, that object has been moved to cool for me. So regardless of what had to happen on the back end to make that happen, now I'm from this moment forward, paying the rate for storing that at cool storage, and then paying the transactional charge around around cool as well. I can do the same thing with this other blob over here, where I can say this blob is going to go to archive and send that to the archive tier. Now, when I come to do things like based on the access tier that this blob is going to be in, that changes what options are available to me. So again, hot and cool, online tiers of storage, time to first byte measured in tens of milliseconds. This blob that I went ahead and sent over to archive, if I open it up, I'm going to see that my portal experience is a little bit different. I can't do things like download that object because it needs to be rehydrated first. So really what we're saying is take that out of the archive and let's go ahead and bring it back to a tier of storage that is going to allow me to download it. And again, that can take some time. It's not an immediate process to rehydrate your data. So just keep that in mind for things that you do send to archive. We have a really nifty option around objects in archive as well. Sometimes as a customer, you want to keep it in archive and not rehydrate it, but you just want to create a copy that's in the hot or cool tier. So you can also do things like clone or copy an object that's in archive and recreate it as kind of a snapshot that's available over in the hot tier for you as well. So sometimes that can help you get around things like early deletion charges within these various tiers. So with that being said, we are through our first module. I'm going to go ahead and pop us back over to our slides here and bring us into the knowledge check. And it looks like we might have a question in the chat before.
Yeah, I was going to say, I
get
think we've
into
got
that.
two, Scott. So while folks are doing the knowledge check, we can go to theirs. We have one
Great.
here from NX269 through Twitch, who is asking if there's no access tier listed in the access tier column, what tier is that blob in?
It's going to be inferred by the defaults from your storage account. So we have kind of multiple flavors or I guess generations of storage account versions. So there's things like general purpose v1, general purpose v2. It's important to note that the things that we're working out of today are all general purpose v2 storage accounts. They support all these things like access tiers. If you've been working with storage accounts for a long time and maybe you still have GP v1, or maybe you have like a blob storage account that's sitting out there. Some of these capabilities might not be available to you on that side. But for a GPv2, you should always see the access tier and whatever it happens to be. Like in this case, again, my storage account, I set it to be hot for everything by default, and then I can change it as needed. I could have changed that to cool as well.
Excellent. And then our next question is from, I hope I'm going to say this right, DJ Eddie, who is asking with Azure Machine Learning, what, I'm going to paraphrase here a bit, what type of storage is suitable for storing folders containing pictures, CSVs, several different types of data?
I mean, for that one, I think that sounds a little bit like this unstructured data scenario that we've been talking about. If you have a need for true folders and true kind of functionality that comes from having folders and files, object storage is probably a great fit for you, but you'll want to look at that hierarchical namespace and the HNS option when you create your storage accounts. That'll give you that flexibility to do things like file folder rename, movement, use POSIX style ACLs, things like that on top of your data.
Excellent. And as these questions would indicate, we have some really, really smart folks who are here with us today, because 100% of you chose correctly with answer B on our first poll. So outstanding.
All good stuff. So I think we had a couple questions on this one. Let's go ahead and get through our second question real quick. Which storage option is better for storing your data for backup and restore, disaster recovery, and archiving? I know what I would pick there, Carl. How about you?
Yes, absolutely. Slam dunk. I know exactly what I would choose.
Hopefully everybody on our side chose Blob Storage. That gives us access to that archive tier. It's a great fit for long-term retention of your data. All right, let's go ahead and get into our next module here. We've got a couple minutes left and definitely a bunch more to bring your way. So now we're going to really get into the nitty-gritty of creating a storage account and what options are available to you at the time that you provision a storage account. So we'll talk about how many storage accounts you might need and how do you rationalize what that is. What are the settings you need on a storage account? Like, when do I actually turn on HNS versus leave it off? When do I turn on things like point in time restore, versioning? Like, there's a lot of different options when it comes to creating your storage account. And then we'll talk about the storage portal as a tool that you can use to create your storage account and get them to where they need to be. So you want to take us kind of through some of the requirements that customers need to consider, Carl?
Yeah, absolutely. So one of the keys is data sovereignty. Many countries around the world have strict regulations on where customer data, user data can be held. So you absolutely need to have a full grasp. The great news is that even when we're talking about our replicated, protected storage solutions like GRS accounts, we make sure that if you choose to have the primary instance in a region with strict controls, that secondary instance does not live in an outside area that would violate those data sovereignty requirements. Of course, cost sensitivity. We talked a lot about the tiers. Understanding the business value of that data and the performance requirements of that data will drive the cost decisions. And there are great tools that can help you understand that, like our partner in the storage migration program, Comprise, can analyze your data, tell you a lot about when it was accessed and how critical it may be to the business before you end up migrating it. So there are great ways to understand what you have before you begin mapping that to an Azure storage service. And of course, diversity of data. You're going to have data that has different requirements from a protocol access standpoint, performance standpoint. You know what those are, understand those, and map to the correct storage platform. Data integrity. Of course, you have to make sure that your data is safe from a perspective in terms of being readable and usable. And that's something that we provide through our strict SLAs and through our protection mechanisms. And then, of course, data security. We've all read stories where company ABC forgot to lock down an object storage account, and sensitive information was exposed to the internet and taken by some bad actors. So make sure to review the security fundamentals, apply the security fundamentals, use tools like Azure Monitor and our suite Security Center to make sure that you have no exposure and keep that data safe. Excellent. So Scott, how are customers going to be able to determine how many storage accounts they may need?
You're going to have a couple options that you really want to think about there. So we talked about kind of multi-protocol access, disks, and files in the previous module. You have to recognize that all of those things live within a storage account. So you might have needs within your application where you just naturally want to separate those. So let's say I provision an SMB file share in Azure Files, and that's going to be used by our HR department. That probably needs to be locked down to just HR. You're not going to want to give the folks in finance or operations access to that, nor would you want to commingle data, like just start uploading, legacy data that you need to get offline and archive. That's just going to live in blob storage. So you can usually segregate and separate based on kind of your application requirements and business needs. You should also think about things in the background, like what are the limits and potential constraints on performance around a storage account. So much like disks had IOPS limits, we have to think about the same things for storage accounts. How much data am I putting in? What is the IOPS on that storage account, or the transactions per second that I can drive through it? What's the ingress, egress look like? And then just modally, like, what are the clients that are interacting with it? You might even find yourself creating multiple storage accounts for the same exact workload. Say I'm an analytics customer and I'm working with data that kind of goes through a life cycle of raw to multiple levels of refinement. Like, let's say we're doing a medallion architecture and doing kind of raw, bronze, silver, gold. Depending on the size of your data sets and the access characteristics of it, you might choose to upload your raw data to one storage account, have a common analytics client access that data in the raw account, be able to egress it out, transform it, push it into bronze, same thing, get it out of bronze, get it up to silver, and go on down the line to gold. So you've got a bunch of different options available to you there. If you feel like you're backed into a corner and you go, oops, I really should have created more storage accounts, you can just go create more storage accounts. You can have up to 250 storage accounts per region per subscription by default today. And we have a capability in public preview that lets you go up to 5,000 storage accounts per region per subscription, which should be generally available in the very near future. So depending on when you're watching this, that capability might already be out there. So now that we know, like, we can create multiple storage accounts and how that comes together, I want to take a look a little bit at some of the constraints around storage accounts and things that you might want to think about when it comes to setting them up. So an important consideration here for you is every storage account has to have a globally unique name. They end up in a global namespace. And because of that, you can't have a storage account that has the same name as another customer. I think that's an important consideration. Like, if you're coming up with, say, like an enterprise naming standard for your storage accounts, keep in mind that the name you want might not be available. So you might need to do things like append a known prefix, a known suffix, and really have a naming convention that you can drive on top of your storage accounts along the way. We talked about redundancy a little bit earlier, so I'm not going to touch on it here other than to say that we have multiple redundancy models. You choose the redundancy model when you create your storage account. If you want to change the redundancy model later, like say you start with LRS and you want to go to GRS, that's just a conversion in the portal and super easy for you to do. Back to that question we had a little bit earlier about why don't I see the access tier? Well, there's actually multiple flavors of storage accounts out there when it comes to generations or versions. If you're creating a storage account through our kind of standard tooling today, be that the portal, CLI, PowerShell, whatever it happens to be, in most cases, you're going to be creating a GPv2 or a general purpose V2 storage account. That's going to give you access to all these features we've talked about today, like multi-protocol access, NFS and SFTP and HDFS on top of Blob, access tiers, data lifecycle management, like all those things are in GPv2 and ready for you. If you're a customer who has legacy accounts, maybe you have GPv1 accounts out there, you can go ahead and convert those to GPv2. Zero downtime. It's basically the flip of a switch and a choice that you can make along the way. And then we also have another legacy account kind, which is blob storage, that allows for only storing block blobs and append blobs. You couldn't mix and match a page blob into that. I've talked a lot about tools that we have available to us to create storage accounts. Today, we've primarily been working out of the Azure portal. The Azure portal is a graphical user interface. It's a website that lets you interact with your Azure resources. If you're more automation driven and you want to work from a command line interface, be that Bash or ZSH or anything like that on the Linux side of the house, if you're on Mac OS, you're on Windows and you want to use PowerShell, we have lots of options available to you there. through first-party offerings in the form of Azure CLI and Azure PowerShell. We also have client management libraries in all the major languages, so .NET, Python, Go, Java, to be able to allow you to create in an automated manner and fashion and work with these storage accounts. We also have offerings in Terraform, Chef, Puppet, if you want to create your storage accounts that way. That's totally an option available to you as well. And then we have our own templating system inside of Azure Resource Manager, where we have ARM templates, or we have Bicep templates as well. So let's go ahead and hop over to the Azure portal again, and we'll kind of walk through what it takes to create a brand new storage account from scratch. So I'm going to come into the portal here, and I'm just going to start searching in the marketplace. I want to create a storage account. Let's go ahead and hit create. Like any other Azure resource, first thing I need to do is select the subscription that's going to live in and the resource group where the metadata around this resource is going to live. This is our Learn Live, and let's see if we can go ahead and get that name. Nobody's actually created a storage account that says Learn Live yet. I'm just going to create Learn Live Storage. Learn Live Storage is already taken. Well, we're going to go ahead and grab Learn Live. We're going to select our region here. So for me, I'm in Florida, like I said earlier with Carl. I might go with East US or East US 2. If your business is, say, centered out of Ireland, you might go with North Europe and be out of our Dublin data center. If you're in the EU, you might be in Amsterdam. You might be in France. Lots of options for you. We have 60 plus regions globally that are available that all offer access to these storage services. Back to that standard and premium access tier thing. Here's where I make that option in the portal. By default, we're going to say, hey, your account should have the most redundancy, which is basically going to be GRS or GZRS. If you want to change this and go to LRS or a lower redundancy model, you can just do that. It's just a nice little drop down away from you within the Azure portal. Let's go ahead and take a look at some of the advanced settings that we can set on our storage account. By default, we require SSL for all transfers. You can turn that off. 100% not recommended that you do, like unless you really have a requirement that goes away. Just leave that on. You want SSL for all your operations. That's a good thing for you. You can control the TLS version that's available to you. And also, turn on that nifty checkbox to say, give me a hierarchical namespace. So that's just a checkbox in the portal. And you'll see it's a little dynamic here. So some things like SFTP and NFS aren't available to me. Go ahead and check that checkbox. And all of a sudden, all those offerings just light up and they're just a checkbox away for you. Your access tier by default, you can choose hot or cool for a GPv2 account. You can't choose archive here, but I will call out that when you're uploading your objects, you can absolutely write them directly to archive if that's something that's acceptable. You don't need read access to it after you've immediately uploaded it. With all our client tooling, you can just go ahead and write straight into archive and be able to enjoy those cost benefits of lower storage costs on that tier immediately. If you want to do files, that is just a checkbox away for you as well. Note that you can do things on this storage account, like back to how many storage accounts did I have? Like enable hierarchical namespace and file shares at the same time. Is that a good idea? I don't know. Depends on your application and how you want to do separation of duties, how you're going to do IAM to this resource within the portal, how you might secure and protect data on the data plane. That's all up to you. We have multiple options around networking. By default, your storage account is going to be accessible from all public networks. You can absolutely privatize your storage accounts. And in some cases, it's actually a requirement. So for something like NFS, you actually have to disable public access, do private access, and basically VNet join your storage account so that any clients that are writing over NFS are going to be on the same VNet or have access to that VNet over over an express route, a site-to-site VPN, something like that along the way. You also have access to a built-in firewall within the storage service. So if you want to restrict access to a known set of virtual networks, maybe you have a set of external providers that you work with that provide data to you, and they're going to know the URI to your storage account or the FQDN to it. That's great. You can absolutely lock it down to a set of IP addresses as well along the way. Data protection by default, we've got some logical defaults in here. Highly recommended that you keep these on if you don't know what they are. But if you know what they are and don't need them, then you can certainly play around with them and get them to where they need to be. By default, we're going to enable soft delete for blobs for you. So that's anytime you delete a blob, we'll actually retain a copy of it for the number of days that you've configured for soft deletes. Think about it as maybe like a recycle bin that you have on your Windows desktop, or if any of you using like SharePoint or OneDrive for Business, use the recycle bin there. Same kind of thing. Super great capability to have on. You can also enable soft delete for containers. So if I delete that entire container or that entire file system, make it available to me, like so that I can go ahead and restore it quickly. And then we have soft delete for file shares as well. Some of these capabilities, like versioning or change feed on your blobs, are only going to be available if you're using just blob storage. In this case, I checked off that checkbox for HNS a little bit earlier. So not all the capabilities are there for me today. That story keeps improving over time as we bring kind of feature parity across all these different protocols that are available to us. Much like disks, you have multiple options when it comes to encryption of your data. Your data is encrypted in transit, like I talked about that SSL setting earlier, and encrypted at rest. By default, it's encrypted at rest with a Microsoft managed key. You can do customer managed keys and manage a key out of your own key vault and your own HSM if that's something that you choose to do. You can also encrypt per object if you would like to along the way. Basically per request, go ahead and encrypt those things. Once you've made all your decisions about what you want to spin up in your storage account, you just come down to that very last screen and we'll do a little bit of validation. You can go ahead and hit create. If you wanted to be able to duplicate this storage account later, like I said, we have templates as well. You've got a nice little option down here at the bottom where you can download a JSON template that you can use to execute the creation of this storage account multiple times. You can also control some of these options around your storage accounts, like should I require SSL for transfers, with things like Azure policy. So your storage accounts, like any other Azure resource, are integrated into the wider Azure ecosystem as well.
Oh, looks like we may have lost Scott there. So I want to emphasize a few things that you saw during the demo. One, those data protection options, things like the snapshotting, the versioning, really important to do. What we talked about early on in the session around the protection levels: locally redundant storage, zone redundant storage, geographically redundant storage. That's a different type of data protection. That's something that protects you from infrastructure failures, making sure that we're maintaining a highly available service for you. When it comes to deletions, either accidental or malicious, when it comes to accidental overwrites of data, that's where those capabilities that Scott highlighted in the data protection tab are incredibly important, and you're going to want to do that. Your responsibility for backing up and protecting your data doesn't change in the public cloud, so that is an absolute best practice. And then the templates that Scott highlighted at the end, that's an example of the automation that he talked about. Just a great way to make sure that you can quickly generate standards-based accounts as you go forward. And one important fact I want to highlight is that you are not billed by the number of accounts that you have. It's the data within those accounts. So, as you're deciding, well, how do I need to architect this to provide access to different groups of users of this data set? How do I need to make sure I adhere to the performance limitations? You're really looking at optimizing with the right number of accounts and not have to worry about cost being a factor in there. That's really decision making that comes into play with performance and tiers and the like. And hey, Scott, welcome back.
Welcome back. I'm going to blame my neighbors. Carl and I live in Florida, and they're always doing things like digging holes and playing with their weed whackers and stuff outside. So glitch in the matrix, but yeah, I'm back.
Excellent. Well, I think we're doing pretty well here. We're coming to the end. Before we do our knowledge check, it looks like we did have a question pop up here. And that is around distributed DNS. It looks like DDNS, distributed or dynamic DNS. I'm a couple of different acronyms could be applied there.
Yeah. So I'm not sure about like how to go with just DDNS and see where that goes.
Oh, you know what? We're good. Never mind. I took that out of context.
All right.
Cool. Yeah. So we can move on to our poll. I think we've got a few minutes left. Excellent. All right, folks, here's our poll. We'll probably make this the final poll question today. And if any of you watching have additional questions, please pop those in. We'll answer those before we sign off here. We've got a few minutes left. Well, let's see what you think about question number 3. Scott, any other tips for the folks who are here with us that we haven't covered? I did talk about the fact that we don't charge on a per account basis, so don't let that drive your architecture decisions. Talked about the importance of enabling features like the snapshotting, the versioning, the soft deletes, just how important that is from a data protection perspective. Anything else you would like to highlight?
No, I think that's all good stuff. I think like if you're creating storage accounts today and this is the start of your journey and you're just getting started with the portal, keep in mind there's a set of logical defaults that there for you. So some of those things like soft delete are on by default. They're there for your protection. If you know what you're doing, go ahead and turn it off. But if you really don't know what those options are, I recommend you keep them on. Like, you may or may not be surprised by the number of customers who I interact with who go, oops, I deleted my data and I need it back. So I think the portal is a great place to start with your storage accounts when it gets to creating them. Like it's going to walk you through step by step, be a very kind of, I think, on rails experience. It'll also help you understand what works with what. If you're using, say, hierarchical namespace, some of those capabilities aren't compatible with other features in the object storage platform, like versioning, and the portal will clearly call that out for you and get you to where you need to be. All that being said, like go ahead and have a play around with it. Like you mentioned, there's really no cost to just creating a storage account. You can create as many as you want, spin them up, spin them down, destroy them, and really kind of have a go at it.
Excellent. And this question was tough. I'll be the first to admit it. It's a long question, which is always tough. And the correct answer was C. So we did not have high success on this one in the polls, but a very difficult question, honestly.
Yep. So Carl, we're going to get yelled at by our producer here. We're going to go ahead and kind of move down to the end based on timing. So why don't we wrap everything up real quick and just to summarize everything for everybody, we've gone ahead and talked about the benefits of storage accounts for you today. Hopefully you've had a decent introduction to how to create your storage account and start working the Azure portal and getting going with your Azure journey. with that being said, you've got some links to resources, and go ahead and walk through the exercises that are available to you. We'd love to hear your feedback and let us know more. And we look forward to seeing you in future deliveries. We're actually going to be doing another one of these next week, diving into that multi-protocol strategy specifically.
Excellent. Thanks, everybody.